Our next speaker is Kristen Pelz. Kristen is a PhD candidate in the Department of Forest and Rangeland Stewardship and graduate degree program in ecology at Colorado State. Her research is focused on stand and landscape scale effects of disturbances and forest management in subalpine forests of the Southern Rockies. She works under Dr. Frederick Smith and collaborates closely with the U.S. Forest Service Rocky Mountain Research Station. Kristen received her BA in Geography and Environmental Studies from Middlebury College in 2006 and has an MS in Forest Science from Colorado State University. Kristen, welcome.
Hi everyone, I'm really excited to be here. Thank you so much for inviting me. I'm humbled to be speaking with... Okay. I'm humbled to be here after seeing some of the amazing presentations.
Can you hold and press the button on that box in your pocket until your mic comes on?
It's on? Oh, there you go. Oh, okay. So thanks so much for being here and having me. I appreciate it. As Justin said, I'm a PhD student, and this is some of my PhD research, but also just sort of a review of some relevant research asking the question of what regeneration in lodgepole pine forests following bark beetles is going to look like. So here's where I'm going with this. First, I'm going to talk about some mountain pine beetle background, which you probably are really sick of hearing about, but I feel like I have to give some background anyways, and some management goals in mountain pine beetle affected forests. And then I'm going to talk about recruitment following the beetle in mountain pine beetle affected forests. First, talking about the conifer species that are present in subalpine forests in the Southern Rockies, and then looking at lodgepole and aspen forests and recruitment there. So, as I'm sure everyone here knows, there's been what has been thought to be an unprecedented mountain pine beetle and just bark beetle outbreaks in the western US and North America in the past decade or so. I'm going to be focusing mostly on this area right here in northern Colorado, but you could see it's an issue that's affected a large area. You could see in this picture, this is in Grand County, Colorado. It's really affected much of the landscape that you can see. It's sort of hard with this projector, but all this gray is dead forest, or at least partially dead forest. So there's been a call for lots of management following bark beetle outbreak. Many thousands of hectares have been slated for management. And actually, you could see here in this graph that some of the most management that's been occurring in these forests has happened in the last 10 years. And actually, the largest amount of clear cutting has been going on. And this is just one district of the Arapahoe National Forest in Colorado, and this is happening across many districts in Colorado and elsewhere in the United States. Some of the goals of this management include hazard tree removal, which makes a lot of sense. You don't want trees to be falling on people or structures, power lines, things like that. Fire hazard reduction, people are concerned that there's all these dead fuels in the forest, and that's going to lead to large conflagrations of the forest. And then forest regeneration, because there's a concern that lodgepole pine is not going to regenerate in these forests without fire or some sort of treatment. I'm going to really be focusing on this third question of forest regeneration in these forests. Hazard tree removal and fire hazard reduction, I think, are really much more of a social issue than an ecological one, and that's sort of a different story with these in these forests, which are, as Jerry Franklin was talking about, usually a infrequent fire forest. So bark beetles, mountain pine beetle is a part of the forest ecosystem. Although the scale and its severity of mortality that's occurred may be unprecedented, there is an important role for them to play, presumably, in these forests. They create a unique regeneration environment, and it really is a moderate overstory cover that is occurring across in the forest compared to clear cuts or fires, things like that. So it's a different regeneration environment than is occurring with those treatments or with the occurrence of fire. And there's a lack of understory disturbance. So the understory, the substrate, is not burned off or scarified by treatment, and so that's creating a unique regeneration environment. So this could be really important to the forest dynamics of these systems. The forests I'm going to be talking about mostly includes these species, lodgepole pine, Engelmann, and blue spruce, subalpine fir, and quaking aspen, just so that we're clear about where I'm talking about. And as I alluded to before, I'm talking about, in my research, central northern Colorado. And that's this region you can see here. This is a map of bark beetle mortality that's occurred and the time when it was detected. And you can't really see the dates very well, but the lightest, it starts in 1996 and then up to 2010 for the dark red. You could see a lot of the forested area in this landscape has been affected by bark beetles. That doesn't mean that that every tree in those areas were affected, but that it was detected by aerial surveys. So I think we've all heard the sort of old lodgepole story that lodgepole necessarily needs fire to reproduce because its cones are serotinous and they're opened by the heat, that it needs a mineral soil seed bed, and that mountain pine beetle always follows fire. However, that's obviously too simplistic. I'm sure everyone in this room understands that. However, that's really a justification that's being used for clear cutting some areas that may not be necessary. Serotiny, as we probably all know, is very variable in these stands. There are some stands with 100% serotiny, but that is not the case mostly. Usually there's variable serotiny and some stands with very low serotiny levels. And the mineral soil seed bed idea that it needs mineral soil may be variable depending on what part of the world you're talking about. And the idea that mountain pine beetle is always followed by fire, that there's this cycle that occurs, is really questionable. Mountain pine beetle hasn't really been shown to necessarily increase the occurrence of fires, maybe the severity, but the occurrence is definitely up for questioning. So following this story of lodgepole pine regeneration, there's this belief that there's going to be really low lodgepole pine regeneration in bark beetle affected forests due to the lack of mineral soil, and that vegetative and advanced regeneration is going to be dominant in the future forests. And that might be the case in many places, but I wanted to examine that a little more closely. Vegetative regeneration has the advantage of not having to establish on the seedbed and the forest floor. So if there's a substrate which has not been disturbed and is not ideal for establishment, vegetative regeneration doesn't have to deal with that. So that's one of the reasons aspen's been predicted to do so well following mountain pine beetle as compared to lodgepole pine. They're both shade intolerant species, but the establishment phase of, or the germination phase of establishment is what's differentiating those there. And then the idea that advanced regeneration is also going to dominate the future forest for the same reason, that there's not that substrate limitation. And then also that lots of shade-tolerant subalpine fir establish under a closed canopy in lodgepole forest in areas where there's a seed source, and then that's going to be able to take over the forest afterwards. This idea is based on this lodgepole story we were talking about, and then also past outbreaks. and short-term studies, which have looked at 3 to 5 years after the current outbreak and the regeneration that's present. So here's just a picture of that idea. Here's a lodgepole pine forest with a pretty dense subalpine fir understory. And then when you take away that overstory, that lodgepole or that subalpine fir is able to release, grow, and continue to regenerate in that environment. Now, for this to occur, it really depends on the residual stand structure that's present after the mountain pine beetle and its composition. This is probably going to occur on higher elevation sites in more, perhaps further north, where there's more spruce and fir in the understory and in the overstory already. So there's not a very high light environment in the understory for those more shade intolerant species to reproduce. And that's something that's been shown to be the case. I looked at some stands that were affected by 1980s mountain pine beetle outbreak. And if you look at this side, this is areas that had at least 20% of the basal area in spruce and fir. And the top row is the 1980s stand structure, DBH distribution. And then the bottom row is in the 2010 and 2011. Now, if you look at the mixed conifer, what I'm calling, with 20% or more of the basal area in spruce and fir, you could see that there's this huge increase of the huge increase in dominance of the subalpine fir. That's this light gray color, 30 years after the outbreak. And that was already, had been initiated in the 1980s. There was already saplings and small pole-sized trees of subalpine fir dominating the understory. And that's just increased with the 30 years since outbreak. However, in stands with much less spruce and fir in the overstory, the DBH distribution in 2010, 2011 looks a lot like it did right when the 1980s mountain pine beetle outbreak occurred. So there is that differentiation between forest types that we have to think about, or forest compositions, when we're thinking about future stand structure. And the idea that the released advanced regeneration is really going to dominate the stand is definitely going to hold true in some situations, but not in all. And, oh, sorry. Before I make that point, part of the reason that this occurs is that subalpine fir has been shown to increase regeneration pretty much linearly with the overstory basal area seed source of subalpine fir in mountain pine beetle affected stands. So it's pretty much able to tolerate any type of overstory shading and just continually regenerate. So that's part of the reason you see this large increase in subalpine fir. But back to the point I was just starting to make, sorry about that. I wanted to look and see when you're going to expect lodgepole pine seedlings and Engelmann spruce seedlings in these forests, and sort of question this idea of substrate limitation and limitation from the light environment. The substrate limitation idea, it's that there's very few patches of mineral soil present in the post-mountain pine beetle forest, and this idea that lodgepole pine needs mineral soil to establish. This is probably especially important in more northern forests where there's dense feather moss and other things in the forest floor. And also, I would argue that it might be more important in the wetter parts of the forest because the negative effect of organic matter on establishment is outweighed by the negative of really quickly drying mineral soil surface in drier areas. And this substrate limitation idea has really led people to say that silvicultural intervention is going to be required for lodgepole pine regeneration. And then another thing is that lodgepole pine really needs that open overstory canopy to regenerate. Regeneration is dominated by fir and uncut forests. That's what we've seen from recent studies in many areas, but these studies have been done really shortly after mountain pine beetle outbreak. So often there are still needles on the dead trees. Trees haven't begun to fall. And part of the reason we're seeing, I believe, that domination by fir, even in forests with very little fir overstory, is because the understory light environment really hasn't changed yet when these data were collected. In Rocky Mountain National Park, it was found there was sparse lodgepole pine regeneration in areas that were dominated by lodgepole pine overstory with very, very little fir whatsoever. But this hadn't changed from before and after the outbreak by the time this data was collected. And other work in Canada, in British Columbia and Alberta, found very few seedlings in 3 to 5 years after the outbreak. And they did raise the point that it might be too soon to see that shift in regeneration environment after the outbreak. And similarly, there's this question of when is spruce going to regenerate in these forests? Because there's not very much many spruce seedlings or saplings in lodgepole-dominated forest, but there's often a spruce component in the overstory. Spruce regenerates in long-term pulses when the canopy closure is not complete. That's been shown by many, many studies in many situations. And there's really little England spruce regeneration under a fully closed canopy. This study from Canada tied Engelmann spruce regeneration to overstory basal area, and that's what's going on in this graph. If you see, this is the spruce regeneration line. There's really only spruce regeneration that's beginning to occur when you get below 10 meters squared per hectare, and it's related to the overstory basal area. That is something that we're seeing the forest with mountain pine beetle activity drop below in many situations. So we'd expect to start to see lodgepole or Engelmann spruce regeneration really pick up as you get down to low overstory cover. In the same situation with pine, Astrup et al., which is where this graph came from, they found that subalpine fir recruitment, that pine regeneration was much higher when you have a lower overstory basal area. Okay, so there's this hypothesis that mountain pine beetle could be allowing spruce regeneration to occur now that needles are gone. And that's something I wanted to look at specifically. So looking at post-mountain pine beetle cover on regeneration in these stands and using hemispherical photos to look at the effect of this varying levels of the outbreak on the regeneration environment. And what we're finding is that there's really a high amount of lodgepole pine recruitment in these forests that had high mortality once all the needles are off the trees. It's hard to see because the greens are all very similar, but there's a lodgepole pine recruiting right in here, a very young one. There's a lodgepole pine that's recruiting in these shrubs right here, and on this vaccinium understory. There are many lodgepole pines in the understory. The story that it needs mineral soil is really not playing out in this situation. They are recruiting on duff, litter, and lichen and moss, and underneath vegetative cover. So once the overstory loses its needles and trees begin to fall, we're really seeing this recruitment response. And that's something you see in pretty much universally, except for where you have really extremely dense grass or carex cover in the forest. And there are large areas that this is the case, and there's very, very little lodgepole regen. And here's a situation where you have all three species recruiting together. This was taken about 10 years after outbreak initiation. You can see there's subalpine fir, Engelmann spruce, and lodgepole pine all recruiting together in this environment. There's a spruce seedling. This is taken this summer. And spruce seedling, lodgepole pine, and advanced regeneration fir that was present in understory. And just another example. So what I'm finding is that there's a lot of regeneration that's occurring in these forests that's really not apparent until all the needles start to fall off the trees and are completely gone, and you have a much higher light environment. And I think that recruitment pulse is going to really change the story about the importance of advanced regeneration in these forests, and probably make us reconsider the way we've been thinking about post-mountain pine beetle structure. So I'm going to shift gears and talk about aspen and mountain pine beetle a little bit. There was a lot of good introduction that Dominique Kulikowski gave yesterday, and so I'm thankful for that. And as you know, aspen co-occurs with lodgepole and other pines in many parts of its range. And there's been a lot of speculation that aspen's going to lead to a huge increase in abundance of, there's a lot of speculation that mountain pine beetle is going to lead to a huge increase in aspen. And so that's been sort of believed to be true, but there's a lot of uncertainties that we need to consider, such as browsing and aspen health in this landscape. So back to this diagram, this shows the diameter distribution from 1980s to 2010 in some mountain pine beetle affected stands. And you can see that there is some aspen component. It's this lighter gray right here in the pure or the mostly lodgepole pine stands, but there's not a huge increase in aspen that we observed from 1980s to 2010. So we were wondering why that might be. There is a pulse of aspen if you look at the ages, but this was not present over the whole site. The aspen that were present were about 20 to 30 years old or younger, so they had recruited after the outbreak, but this wasn't something that had occurred in a way that really affected the stand structure. So to look at this question, we surveyed aspen regeneration at 30 sites across north central Colorado and in southern Wyoming. So basically from up here all around to down here, there are 30 stands we visited based on their FS-veg basal area characteristics. And a few things we were concerned about in our survey was looking at aspen decline that was present in these lodgepole and aspen mixed forests. Aspen mortality is about 21 to 43% according to FIA data in these counties, and that's way more than the 11% mortality from a random survey of aspen in the same area. So that we're concerned that there might be some sort of additive effect of sudden aspen decline and lodgepole pine mortality surrounding the aspen, causing them to be even more stressed and causing more mortality. And what we found was 2/3 of surveyed stands did have large patches of aspen decline with very little regeneration. We found that the majority of stems were browsed in most stands, and we were pretty surprised by that. Across the whole area, and I was not expecting that at all. So there were some notable exceptions where things were very steep and where aspen clumps were protected by down logs. And I'll just show you a couple of pictures of that. There's a very steep stand with prolific aspen regeneration. And then here's some aspen that were protected by down logs. You can see that these are growing great, and the down logs are 6 to 8 feet high stacked up. But that's only protecting them where there are down logs present. I just wanted to show you some quick data from an MS thesis done at OSU. There's evidence that the jackstraw does protect aspen trees and will lead to recruitment only where there is jackstraw present. And that's what this diagram is showing. And then also Justin DeRoe's work in southern Utah that shows aspen that recruited to be over the browse threshold were really only present where cattle and other animals were unable to walk because they were on a really rocky lava flow substrate. I'll breeze through this. I'm sorry I ran over. But this is what's typical in a lot of places. Really, these aspen are often 5, 6, 10 years old, and they're not growing above knee height. So one of the big culprits you might not be able to see very well is here. It's moose. There's 2 moose here. And in north central Colorado, moose are becoming a huge issue, I think. 24 were introduced in the 1970s, and we've exceeded the target population for the Colorado Division of Wildlife already. And I think they're having a huge effect. I've seen herds of moose, which I don't think was normal. And all of the willows in some of the areas that I see the most moose are starting to be browsed down to below knee height, and I think they're having a big effect on aspen as well. To predict where aspen's going to be across the landscape, we really need to know these factors, but that's sort of a different story. And I don't think I have the time to go into this, but as Dominic alluded to, there's a big question about fire and mountain pine beetle, how those will interact with aspen. So the places where there's a lot of regeneration concern for management, I believe, are where there's very dense grass and sedge cover, and where there's aspen decline patches, and especially where there's aspen decline patches with intense browsing, where there's a few suckers that are trying to regenerate but not able to do so. So I think that places where there's a lot of browsing, using some exclusions would be really important, although tree fall may protect the aspen regeneration if possible, if the trees fall in time. And there's some larger scale questions. This is really talking about the stand scale, but if you're concerned about species composition changes at the landscape scale, looking at management options might be more appropriate. But for regenerating forest at the stand scale, it seems like these forests are pretty much able to do it, except for those exceptions I was talking about. With that, I want to thank my advisor, Skip Smith, and my collaborators at the research station. None of this would be possible without them. So very much thanks to them. And if there are any time for questions, I'll take them. Okay. Sorry about that. In the back?
So the photograph you showed of aspen regenerating following mountain pine beetle also had aspen in the canopy, which makes me think that the clones must have been present there prior to the outbreak. If you were to visit that stand prior to the outbreak, you may have seen little tiny sprouts when you come up.
Right.
And so my question is, have you seen any evidence of aspen regenerating where the clones did not exist prior to the outbreak, either via expansion of the clone or maybe regeneration from seed?
I've definitely seen expansion of the clone, but not further than you would expect the roots to exist already, not further than 1 tree height. We've selected stands based on presence of aspen in the overstory, but I did dig up 1 seedling. I'm pretty sure it was a seedling. That there was no aspen around at all, and it was all alone, and I'm pretty sure it had established by seed. So I think that that's a possibility. Yes? Oh, sorry. I'm sorry.